So this exercise is 10 from section 10.4 on page 286, and it's called Applications to Modeling. Okay, so basically we're going to see the real life examples of where Newton-Raphson method or any other iterative processes are used. Okay, so this example 7, it talks about price of a car in S pounds, X years. So S is in pounds and X is in years. I always find it very useful to write this down because sometimes they catch you out by having the units different to what they have in the question, and then students forget to convert and then they get a wrong answer. So always have the units written here. The price of a car in S pounds, X years after purchase is modeled by the function, and we've got the function f of x equals 15,000 times 0.85 to the power x minus 1,000 sine x, where x is a positive value, okay, because obviously x is years and it can't be negative. It says use the model to find the value to the nearest £100 of the car 10 years after purchase. So 10 years after purchase, I am going to substitute x equals 10 into this equation or function. That's 1,000 sine 10. Okay, and let's see what I get. So I'm going to have my calculator in radian mode. Okay, so 15,000.85 to the power 10 minus 1,000 sine 10. And I get 3,497.13, but they said round this to the nearest 100, so my answer is then going to be £3,500. Now this is the key thing to remember here. In any iterative process question, always have your calculator in radian mode, okay? Otherwise you're not going to get the correct answer if you had a... Okay, part B. Show that f of x has a root between 19 and 20. So I'm going to substitute 19 in there, and if you remember from your very first exercise of locating roots, that there is going to be a sign change. Okay, so what I'm going to do is I am just going to change it there, and I get 534, which is positive. Then I am going to substitute 20 in there, and I get minus 331.55, and that is a negative. So there is a sign change showing at least one root between 19 and 20. Okay. Part C says find f dash x. So they want us to differentiate. Okay. So if I differentiate a constant with a power of a variable, I'm going to write that here. So if I had something like 2x, and if I was to differentiate that, I'll get 2x ln 2. Okay, so this would be my derivative. That's just an example. So I'm going to apply that here, and I am going to get, if I did that, I would get 15,000. So this constant will just come out, and I'm going to just differentiate this bit, which will be 0.85x ln 0.85. Okay, minus, we all know that sine x differentiates to cos x, so that will just be 1,000 cos x. Okay, that's my derivative all done in one line. Now part D says, taking 19.5 as a first approximation, so x naught is 19.5, apply the Newton-Raphson method once to f of x to obtain a second approximation for the time when the value of the car is 0. Okay, give your answer to 3 decimal places. This is just another way of them saying apply the Newton-Raphson method for x naught equals 19.5 and just do it once. Okay, so I've got my f dash x and I've got f of x, and I need to substitute 19.5 into both of them so I can apply my Newton-Raphson method. Okay, so f of 19.5, if I substituted that in, I would get 25.0693. If I substitute 19.5 into my derivative, I would get minus 898.3009, and so on. And I'm only applying this formula once, so that is what I am going to be doing. I've already got the values of both of these, and I've got the value of this, which is 19.5. And when I substitute all of that in, I get 19.528. Okay. Okay, and part E says, criticize this model with respect to the value of the car as it gets older. So in reality, the car can never have a negative value, and this model is not reasonable for cars that are approximately 20 or more years old. So what's going to happen is, if I was to apply the Newton-Raphson method a few times, I will get a negative value, and that's actually not possible. So what I'm going to write is, the car can never have a negative value, so not reasonable for x is greater than 20. Okay, so basically, if you were to apply Newton-Raphson for x is greater than 20, you're going to end up with a negative value, and that's not possible. Okay.